Hey everybody, alright, so let's actually implement this insertion sorting method. Now I know some of you guys might be saying, wait a second, Mr. Sands, where are you? Why aren't you showing your camera? Real talk, hair looks whack today, so you're not getting it. Sorry. Alright, anyway, so we have this insertion sort method, which if you recall the bubble sort method, it's essentially the exact opposite. With the bubble sort method, what we were doing is we were moving the largest element that we found to the right every single time between a pair of two elements. And what we're doing here is we're just checking each element in an array. And if we find one that's smaller than the one on the far left, we move that one down. All right, so let's get going. So first thing, I'm just going to put a little note in there for you. This is essentially just boiling down what it says here for each element in our array A, and this is just the array that you see in this example over here. For each element in this array, we're going to say, all right, well, if A minus 1 is greater than A of I, swap those elements. So essentially, take a look at these two pairs. If this one's greater than that one, swap them. And that'll move the smaller one down the line. Then you take a look at, well, this will be 8 and this would be 4. Take a look at those and you swap them. And you keep on doing that, and it'll move the smaller ones to the left and the bigger ones to the right. And you just reiterate that until you're done. All right, so how can we implement this? Let's make a static function. So public static void. We'll call this insertion sorts that accepts an integer array. You know what, in fact, I'll accept, yeah, we'll just do it with integers, that's fine. You could do it with doubles, but I'm gonna do it with integers. It's the same function. And then we're just going to loop through this array for int I is equal to 1. I is less than array dot length I plus plus. All right, and so we're going to be checking some value. We'll say int value is equal to our array at index I, which, you know, it'll start off at 1. Int test index will equal to I minus 1. All right, this is the index right before that one, so currently this is 0. And we'll say while test index is greater than or equal to 0, and our array at test index is greater than our current value, what we'll do is we'll say array of test index plus 1 is equal to array of test index. I promise I'm going to explain all of this in a second, so don't worry if you're like, holy crap, what is he doing? We'll decrease the test index by 1. And then we'll say array at test index plus 1 is equal to that value. All right. So what is this doing? Let's bring up a paint real quick. And I'll just draw it out. All right, so we have, let's do a shortened version of this array. So let's say we have 8, 2, 4, 9, right? We have these two variables, right? We have value, which I'll just shorten to val, is equal to array at index I. Well, we defined I as 1, so that's currently equal to that. All right, so we'll say value is equal to 2. All right, we also have something called test index. I'm just going to call TI. And we set that equal to I minus 1, which currently is 0. All right, so that's index 0. And we check. All right, is our test index greater than or equal to 0? Yes. Is our array at test index greater than our value? All right, well, let's take a look. Is 8 greater than 2? Yes. So then it said, because those conditions are true, that means we can do a swap. All right, so because those conditions are true, we can do a swap. And what that says is say array at test index plus 1. So that says array at I right over here. All right, because test index was I minus 1. So if you say test index plus 1, it's just I. All right, and in fact, if you wanted to, you know what, let's just keep it like this because I could change and this might not. So yeah, test index plus 1. All right, so we set that to array at test index, which was 0. So this 2 becomes an 8. So we can cross that out. We can make that an 8. Now, we don't have to do what we did in the last one because where we had a temporary variable, because the value that was here is still in our value variable. All right, so then we say test index minus equals 1. And what that does, it says, all right, well, test index is now negative 1. It just brings it back to see, all right, can this 2 also be, you know, is there anything before the 8 that is greater than the 2 as well, so that we can move it multiple spots at once? Well, no, 8 was that first element. So when we go back up to the top of the while loop, you'll see test index, now that it's negative 1, does not satisfy this first condition. It's not greater than or equal to 0. So this while loop stops, and it says, okay, well, we can't check any more values, so this 2 must go here, right? Because that's the last value that we checked it against. And that will say array of test index plus 1 is equal to value. So negative 1 plus 1 is 0. This becomes 2. I know that sounds a little bit confusing, but I mean, you see, we essentially just swapped these two things. All right, let's look at that a little bit farther down the line. All right, so we finish this loop. We go back up to the top of this for loop. I increases to 2 now. And in fact, let's have an I value just there. Anyway, so I is 2. Value becomes array of I. Well, array at index 2, that's our 4. So this value is now 4. All right, test index becomes 2 minus 1, so that becomes 1. All right, and then we do this while loop. What is test index greater than or equal to 0? Yes, 1 is greater than or equal to 0. Is array at test index, so is array of 1 greater than array our value 4? Well, yes, 8 is greater than 4. We can do a swap. All right. You know what? Let's actually increase this array once, just because I want an example where we do multiple swaps. All right. So we can do a swap, and so we do that. We say array at test index plus 1, which is here, is equal to array of test index. All right. So then this right here, this 4 will be replaced with this 8. Then we say test index minus 1. So this becomes 0. And we check again. We say, all right, is test index greater than or equal to 0? Yes. Is test index greater than array of test index greater than our value? Well, is 2 greater than 4? No. So we don't do a swap. And now we say, all right, array of test index plus 1 is equal to our value. So that says array of index 1, because 0 plus 1 is 1, becomes 4. I know it's a complicated way of saying it, but it's essentially just, it keeps on checking down the line to see if we swap. All right, so now we have 2, 4, 8. Let's keep going. This becomes 3. Then value is equal to array at 3, so that would be that 9 right there. And test index becomes I minus 1. So this will be at 2. This one will be a real quick one. We check this condition. Is test index greater than or equal to 0? Yes. Is array at test index, so is test index is 2, so is 8 greater than our value, 9. Is 8 greater than 9? No. There's no swap that needs to happen here. So we immediately skip that one, and we can just do that last one. Now I goes up to 4. Here, test index will become 3, and our value will become this 3 right over here. All right, now last time we need to check this. We take a look. All right, test index greater than or equal to 0. Yes, 3 is greater than or equal to 0. Is array of test index, which is this 9, greater than 3? Yes. So what we're going to do is we're going to say, all right, well, array of test index plus 1 becomes array of test index. So this becomes our 9, right? Then this value decreases, so this goes to 2. And then we loop back up. Is 2 greater than 0? Yes. And then we have to check again. Is array at index 2 greater than our value? Well, our value is 3. Index 2 has 8. Is 8 greater than 3? Yes. So we do another swap. So now this says, well, index plus 1. This 9 becomes an 8. Right? And then our test index goes down again. Down to 1. So now we check. All right. Is 1 greater than 0? Yes. Is array of 1 greater than our value? Well, at 1 we have this 4. Is 4 greater than 3? Yes. So then this 8 becomes our 4 because we're just shifting it down the line. All right. And then this 1 becomes a 0. And we keep trying. Is 0 greater than or equal to 0? Yes. Is array of index 0, so that's this 2, greater than 3? No, 2 is not greater than 3, so no more swaps happen. So now array at index 1, 0 plus 1, so this 4 becomes 3. And I know it's a little messy, but that essentially now gives us this array 2, 3, 4, 8, 9. Okay, that was way longer than I wanted it to be, and if you decided to skip the explanation, I understand it. If you have any questions, please throw them in the Discord. But that's been insertion sorting. I wish we were in the classroom. Gosh, I would have had a great lesson where you guys all moved around the room. But you know what? We're doing what we can here. Thank you so much for staying. Don't forget to do the attendance, and I'll see you in the next one. Oh, you know what? I'm being dumb. Before, hopefully you didn't leave already. Let's actually implement this. So if we use insertion sort on A, and then I'm just going to use this for loop to print out the values for int I for int I equals 0, I is less than or equal to a dot length I plus plus. Why don't we just say system dot out dot println a at index I, and you should see this prints out on your console every element in order from top to bottom. Assuming I didn't make a mistake. Yep, 2, 3, 4, 6, 8, 9. Which is saying, as it's iterating through the array, it says at index 0, print it out, so it prints out the 2. and index 1 printed out, prints out 3, 4, 5, 6, 7, 8, 9. Sorry, 4, 6, 8, 9, which is this array sorted. So obviously this insertion sort worked. All right, now go and have a great day.